Alright, folks. Let me check on this really quick. Apologies for the delay. I ended up having additional technical difficulty that I needed to reboot my computer. So that held me up in addition. Alright. Looks like we're ready to go. I just checked the stream. Everything looks good on my end, but do let me know if the audio. I know there's probably still a buzz behind my microphone. I'm still hopeful that I'll be able to get that removed at some point. I don't think I've figured out how to make that stop just yet. Let me check though. Okay, we're on headset microphone. But yeah, any other issues? If the text is too small or anything, still getting used to streaming on this new computer, so just want to make sure that everything is good. Feel free to just pop that in the chat if anything comes up. Okay. So last time I went into detail about tuple immutability. Oops. About tuples and immutability. Kind of talked about mutability versus immutability in general, and we looked at tuples and juxtaposed them against lists. So we can think about, and I'll kind of recap what we talked about last time. I won't go into as much detail this time, but we kind of looked at the two against each other as, you know, between tuples and lists. We looked at the two against each other as similar types, with the difference being that lists are mutable and tuples are immutable. And there are pros and cons to both, right? Sometimes it's preferable to have an immutable type like a tuple, and sometimes it's preferable to have a mutable type like a list. And there are various factors that kind of weigh into that. And the way you can make an informed decision is just by understanding basically what that means, you know, the impacts of that, and the potential the potential downsides of, you know, choosing one versus the other. Yeah, okay. So, again, just to kind of recap the conversation on mutability. Let's do a dir of a list and a dir of a tuple, and we'll just look at these side by side. So dir, I'm just in the IPython live terminal here, and I just called the dir function. That's going to give me, dir is short for directory. It's going to give me all of the types that are built in, or excuse me, all the methods and properties and stuff that are, or I guess just methods, excuse me, that are built in for a given type. So these are all the methods for lists. Whoops. There it is. And these are the ones for tuples. And of course, I am just actually ignoring all the dunder methods and stuff, things like that. Yeah, those are for an entirely different conversation, right? So, real quick here. Whoops. I'll just do this. Okay. So, last time we just looked at, you know, tuples only have the two methods built in. And if we actually look, this looks like lists have a lot more going on. But everything, so lists also have a count and index method. like tuples do. We've got count and index, and they're going to behave exactly the same. So the count and index methods for lists and tuples are going to work exactly the same as the other. So if you understand it in one, you know how to use it in the other as well. So count and index don't cause a change in the value of the object it's called on. All of the rest of these do, arguably, except for copy, which doesn't change the value, but it literally duplicates the object in memory. So the only reason that copy should exist, the only reason you would want to duplicate something in memory is so that you don't alter the original copy. So the reason that it's useful to have a copy method is in the context of having other methods that can mutate the object so that you are careful about which object you're mutating. So that's why lists have a copy method. But if we look through here, append, clear, we just talked about copy, extend, not index, insert, pop, remove, reverse, sort, all of those that I just selected there, all of those cause a mutation in the object that it's called on. And when we're working with an immutable type, when we're working with tuples or any other immutable type, we can actually basically mimic the behavior of these with concatenation, slicing, and indexing. So we can use that to manipulate variables and get transforms that give us technically different objects, different copies of the tuple, essentially different copies of the tuple. So we may end up duplicating the tuple sort of automatically every time we get an alternate version of it, and manipulating the variable in such a way that we can make it feel like tuples can actually do these things, even though we're doing it with different copies of objects rather than altering one object in memory. So anyways, so all that to say, it at first glance it looks like lists have a lot more options, that there's a lot more that you can do with them. And it's not really that there's more you can do with them, it's that the way it happens under the hood, the way you perform actions, in the code might look a little different, but the way that those actions are performed on the computer are different. They're either performed in place in the case of mutation, or they're performed, quote, out of place in the case of immutability, like tuples. And that's really the thing to understand there, is that it's not that one type is more powerful than the other, it's that they're basically capable of the same things. It's just that how they go about doing those things is different, and understanding that how is, that's how you would make a decision about, which behavior you would prefer in a given situation. So it's just a matter of knowing what's available to you and choosing the right tool for the job. But other than that, they're basically really similar types. Okay, cool. So we left off last time, and I didn't get through this last one. I do see we have a question here, and I want to get to that, but since we have this last question from last session just kind of dangling out here, I'll get through this, and then I'll take the question that's been posted. Sorry to keep you waiting, by the way. Okay. Oops. Okay. So write a function called tuple creating tuple. This function takes 3 arguments: name, age, and job. Tup. We'll do this. Okay. Oops. Let's see. There we go. Just kind of stubbing everything out here. Just giving myself a template to work out of. And we'll just do this. Oops. Some name, some age, some job. We'll do that. All right. Takes these three. The 3 tuples are in parallel since they contain the same number of items. Each item is given an index at the given index corresponds to the other items in the same index across the other tuples. That's an example. So this function should return a single tuple of all the values given. This function should return a single tuple where all the values given at a given index are in tuples of their own of the data for the same person. Okay, so our output, if I do, let's think of just some names here. So let's say Jane and Sally and Jesse, and we'll do ages. Well, let's say 44, 28, and 57. And then I'm going to be all a little OCD about this. Okay, that's better. And then for our jobs, let's say data scientist, teacher, and Fisher. We'll just say Fisher. Cool. So for these, I'll make this, justify these real quick. Oops. There we go. Okay. So for these inputs, basically, what I'm going to do is, I knew it wasn't going to work. I'm going to want to group these in, tuples like this, and the output will contain these sorts of tuples, etc. We can imagine the same pattern for the other 2 entries as well. So I'm it's kind of like I'm taking, if you look at this, in a way, these are kind of like rows and columns. I mean, it's spread across 3 variables, but it's almost, in a way, like a little spreadsheet data, right? We have sort of each variable is like a row, and what I'm doing is taking the I'm flipping the rows and columns kind of. So I'm putting each column in its own row, and then the output will reflect that pattern. So what I did here, and I've talked about this kind of thing with a few people lately, a number of people. So you know, if you're watching and we've talked about this recently, I'm not just you know, not just one person or anything, but it's a number of people that I've talked to about like building schemas. So this is what I would call a schema, just a data schema. The root word is schematic, so just some scheme, some kind of outline of what I expect. And I'm generally, the way I write these out can look kind of formal, but and it's good to be consistent. It's good to, if you need to, include types, right? Like here I can just see that this is a tuple containing tuples, a tuple of tuples containing a string, a number, or an integer, and then another string, right? So the types are simple enough that I don't need to annotate them, but when you start getting into dictionaries and, you know, nested tuples or nested lists and things, it can be good to be just be as explicit as possible. And a schema, to me, the job of a schema is to just give me a clear idea of where I'm headed. So that's what I'm doing here. Let me clear that up. Okay. Cool. So let's just do this. So I think, can I just return zip? Can I just zip these? That's going to return the zip generator, but I want this to be a tuple. I think that's all I need to do. Yep, that's all I need to do for this one. Kind of a bit of a cheeky solution. So zip has this. I know whenever this is one of those things like, you know, as you continue to program, you know, like you pick up little kind of tricks and little patterns. So I know when I have something that's structured like columns and rows, and I want to flip the row into, or the column into being a row, I know I can use zip basically for that tool. Another way of looking at that, it doesn't sound the same, but a way of wording the same problem is when you have parallel data, parallel lists, parallel tuples, whatever, and you want to represent the items that are in parallel, that are aligned with each other simultaneously. Zip is the answer to that. And another, like I said, another way of describing that is you're turning columns, which is all the data associated with each other, into rows. Cool. 1 second, I'm getting a phone call actually. Apologies for that delay, folks. I'm awaiting a call, and I kind of have to just I kind of have to answer my phone when it's ringing for the time being. But usually, if I get called in the middle of a stream, I do ignore it. But okay, thanks for y'all's patience. So let's try to submit this and see if it'll work. Hola. And if we look at this, you can see they're doing something pretty similar with using range and appending to a list. Just as a variation on that, right? I'll write that solution. We could have, I'm just going to call it res for result. We'll have it be a list, and I can say for I in range len, and we could pick literally any of these. Names, age, or job, doesn't matter, since it was given as a constraint of the problem that all of these will have equal length. We can assume that they'll have equal length, and we don't have to do any correction for potential variances in length. Just return res, and all this is doing is res.append these sub I. That's all that's doing. So we're just indexing in. We're using that the mutability of the list just to have something to append to, and then just casting as a tuple, just like that. So that'll work too. Oops. Of course. Oh, right. I can't pass multiple arguments to append, so I actually have to pass one argument, which will be a tuple that contains those three things. So let's just make that a little clearer. So appends now has a single argument that is a tuple. Okay, so that'll work. Alternatively, if we didn't want to use a list and then cast as a tuple, I mean, this is a fine way to solve this problem. I don't have any personal problem with it doing it that way. We could start res as a tuple like this, and we could concatenate it with a single element tuple whose item is this multi-element tuple, which is, it's kind of a weird concatenation and nesting of tuples thing, but this will actually work to the same ends, and we don't have to use a mutable type if we didn't want to. So that's another way to do it, and it uses all tuples. Cool. All right, and then sets are up next, but we've got another question. We've got a question here, and apologies for keeping you waiting on your question. Let me get to that. Let me start up Slack again. Okay. Copy the link. We'll go to the link. Oh, cool. Thanks for being patient. Appreciate it. And let me grab the code provided. Okay. Conditional statements, and this is issues with number 17. All right, we'll see. Write a function. Okay. We'll just steal this example as a test. Okay, so write a function called blah blah blah, given 3 words. The function returns the length of the shortest word. Conditional statements. Interesting. It takes in only 3 words, so you know what I would do is we could return the men of, oops, the lengths of the three words, like this. Like that. That should do it. Let's see. Returns the length of the shortest word. So yeah, so this will do it. It should, if I'm understanding the question correctly. Cool. Okay. So let's see how you were thinking about it and see what we can get out of this. So let's look at how this is going to work here. So this is going to return the correct number, it looks like, but if we do, what if we do this in a different order? That's going to give me 2. That's what I thought. So let's do different orderings of these. So we know that no matter what the order, we should get the same result here. Oops. Wow. Let's see if I can just hit one key at a time. ABC, ABC, ABC. Okay. So in any case, we should see 1. Forgot a comma. Okay. So we get 1, 2, 3. Okay, so what I'm seeing here, this is going to return num, or len I, every time the length of I is less than the men length of this seems to me like kind of like an upper bound sort of solution where you make an arbitrarily high upper bound. This is probably a safe bet too, because I am willing to bet a lot of money that there aren't any English words with this many characters in them. So that's probably a safe bet. 99,999. Okay. So here we have a list of the words. We loop through that, and then if at any point the length of any given word is less than this really high upper bound, which it always will be. So this is effectively like saying if true, which means just we don't need the if, and we can so we'll just ignore that, and we can just say num equals len I. Since we're returning that only using it once, we can just return len I, and then this turns into the return in a for loop problem, or return in directly in a loop. Now usually when I talk about this, I say you don't want to put a return inside of a for loop unless it's under an if statement, which this was, and I just ruined that, right? But hopefully it's clear that I'm saying, that this is effectively, since the length of any word you could choose in the English language is definitely less than 100,000 letters, essentially. Then this return is always going to run for the first word encountered, right? So what we want to do is compare this. We could think of a system to compare the length of every word to the length of every other word. And if at any point the length is smaller, then we'll record that smallest found length and then go on and keep checking to see if there's something that's smaller than that, right? So we could do for let's do this. For word 1, we'll call it W1 in A, and for W2 in A, we can do this. We'll return outside, and let's do this. Shortest equals, oh, I guess we could do, I'll just reuse this min one here. Yeah, so we could say if len w1 less than len w2, min 1 equals len w1, I think. This solution feels tricky to me. Okay, and we also need to say if length of the first word is less than length of the second word, we want to record its length. No. Okay, the easier way is going to be to do that and then record it like that, and then we don't need W2. I don't know what I was thinking there. Okay, so I think this will work as well. Let's comment out that old solution. Correct. Okay. So yeah, I think like just from what I'm seeing, like this is the sense that I get is like this is where you were kind of heading with this. And I'm just gonna kind of clean it up a little bit, see if I can just give things different names. Okay. Yeah. Another way to get around this upper bound thing is to have like a find max length of 3 words, and then this will be basically the same logic, except instead of shortest we'll have longest, and we'll start longest at 0 because we can't have a word that exists that has no characters in it. So that'll help. And then just the opposite operator. If the length of word 1 is greater than longest, which it will be because it's 0, then we can do that. And then we can kind of cheat, and we can reconstruct the longest, the maximum word length like this. And then that saves us from having to do, I mean, even though we can guarantee, I'm pretty sure we can guarantee that there are no English words that are even close to this long. I'm certain of that. But if it does feel a little weird to do that. So if you want to get around that, you could do the max and then just set shortest equal to the max, and then that you can work your way down from there. The reason that max is easier to find is because, like I said, you know where longest should start. Like your lower bound is 0. It's obvious. Whereas, you know, the hypothetical upper bound for a string of characters is there's a, I mean, n. N is the length of a string of characters, meaning that we don't know. It could be any arbitrary length. So the upper bound essentially has to be infinity unless we know how to determine objectively the upper bound, which can be done like this. So this could also be an alternate solution. And let's verify that. And that works as well. Then you end up with two useful functions, which is kind of neat. But, you know, in reality, this is what I would do. Just the get the lengths and take the min of that. I want to do like iterations of this problem because it's kind of, you know, it's more likely that we would end up, okay, I'm just going to do it. I don't see any other questions. So I'm just going to do it. I'm going to do an iteration. A more realistic version of this problem might be instead of taking in just three words and getting the min length, we might have a word list that has an arbitrary number of words where we don't know what the we don't know what the minimum, or excuse me, we don't know how many words are in the list, right? So we'll just return min of res here, and we'll say res equals a list, and I'll just accumulate lengths into this. So for word in word list, res dot append len word. And you know, shoot, maybe we could even do like make this a set, you know, because we might have duplicates. We'll set dot add, and then, you know, it doesn't matter. We just want the length, right? We don't need to know the word in this case. So yeah. And if I wanted to get, I guess I could actually get this to pass. Yeah, I could actually get this to pass like this. So we could do star words list. This is actually going to give us a tuple. And I'll just, as is traditional, I'll call this args. Star args, I'll use star args, which gives me a tuple of all the arguments passed, right? So I could actually, in theory, what's going on here? Why is my highlighting look weird? Okay, I think it's just this highlighting schema. I haven't got my new highlighting working, or my old highlighting. I just need to, I just haven't imported it over, so it just doesn't look right to me. Okay, that didn't work. Dict object has no attribute add. Oh, right. Like I said, it's funny, I say this all the time, don't use curly brackets to start an empty set, use the set constructor function. I still do it sometimes, obviously. Cool. So that'll do it as well. And then, so the reason to prefer doing it this way is because now we can take an arbitrary number of arguments and find the minimum of that. Okay, cool. That's enough. Probably enough iterations on that problem. Cool. I'm not seeing any other questions. To the person asking, let me know if this was helpful. If you have any other follow-up questions, I guess is what I'm asking. But yeah, Yeah, so to anybody, the floor is open. Feel free to paste in another question if you've got one. I'm not seeing anything. So it looks like we've got sets is up next. That's convenient because I just used a set. Remember that? Let's see. Can I move this over a little bit? That'll look good. Looks good. There we go. Okay. Cool. Glad that was helpful. All right, unit overview. Skip it. So, I would say sets are. Let's talk about sets. Sets are. I don't think they're the most complicated type, but I think they can be particularly hard to. Sometimes they can be tricky to understand. They're not a particularly complicated type, but it's sort of a there's sort of a similarity with understanding sets. Um, how do I put this? It's like they seem like another kind of list. And you look at tuples and lists and you say, well, tuples are another kind of list, but they're immutable. They're like immutable lists. And if you look at a set, it can be like, okay, well, here's somehow a third variety of list-like type. And the thing is, sets are not like lists. They're really not. Tuples are like lists. Sets are not like lists or tuples. So they can be deceiving because when you look at them, when you print one out, let me just let's actually go back to this example here. And I'll just print this out. We'll just return the set here every time. Right, set 1, 2, 3. You know, these look like lists because it's just brackets. You know, a list is square brackets. A tuple is parentheses, and a set is curly brackets. And if a list and a tuple have a lot in common, then it would follow that, given the way they look, that a set would also have a lot in common with the other two. So there are some differences, significant differences, that mean their use case is pretty wildly different than lists or tuples. With lists or tuples, where you can use one, I think it's safe to say that, like, in terms of algorithmically, you could use the other. I don't know of a problem where, like, I absolutely couldn't use a tuple instead of a list, or vice versa. They're basically interchangeable. There might be a performance or like there might be a performance issue with one over the other, and that can be the case. It's one doesn't outperform the other in all cases. There are certain cases where one is distinctly beneficial in terms of like performance or potentially maintainability. There are other factors, right? So there are reasons to choose a list versus a tuple, but like if I'm just talking about like how do I put together a working solution, like thinking just in terms of the algorithm itself, they're interchangeable. Whereas a set cannot do the job of a list or a tuple, like explicitly cannot. So in this case, if we look at this, it's kind of interesting. the way that the set got printed out in all three cases, right? If this were a list, let's look if this were a list. Kind of convenient, this problem that we went through, because I can kind of demonstrate this. So remember that I got, for all three of those calls, I got exactly the same set printed out. But if I use a list, I get different lists, right? They all, in all cases, they contain the same elements. But a set, the set, they came out in a different order than they went in, right? So, and we know that because the list preserves the order that they went in. The order that things are stored in a list or tuple, the order in which elements of a list or a tuple are arranged, order in which those elements are arranged, is meaningful information. In other words, it matters to the type, right? That ordering, the order of elements, matters. With a set, we think about sets similarly to the way we think about dictionary keys or dictionary items, right? That the order is trivia. The order, if they come out in the same order that they got put in, then whatever, right? Like the Python will choose how to optimize the ordering of a set or a dictionary based on a number of different factors that you can think about, like you quote, you don't know about those factors. It's sort of like a black box. So in this case, they're sorted. And I've noticed that on recent versions of IPython running locally on my machine after like November, December last year, small sets will tend to come out sorted. So if I ran this 100 times with sets, it'd probably come out in a sorted set every single time. And you can't even count on that, right? Like sometimes sets will be ordered, but I've also seen sets unordered, right? So when the order of the information matters, which quite often it does, a set is useless. It's not a useful type. It is not something you want to use if you intend to store information and retrieve it in the order in which you arranged it, because it literally doesn't have an order, or at least we think about it that way. For an analogy, if some of you may have heard me use this analogy before. If you have if I arrange some elements on if I arrange some books on a shelf, and I say, like, hey, would you hand me the third book on that shelf? Well, you'd probably used one-based indexing, and you'd start at the first book and count that as one, and then go to two, and then you'd find the third book on that shelf, and you'd pull it off and give me the third book on that shelf. If I handed you a box of books that were like haphazardly like on top of each other, and I say, would you hand me the third book in that box? You know, you might look at me like, what does that even mean? Like, what's the third book that I just happened to randomly choose? Another analogy, or the one I usually use, is like a set is, rather than like an array of ordered elements on a shelf or in a line or something, you can think about it like a jar of jelly beans, right? If you think about like what does it even mean to like retrieve the 15th jelly bean from a jar of jelly beans, how do you determine where to start and what comes next? There is not an obvious place, right? In that scenario. So you can think about a set like that. It's like a grouping of things in a pile. So the order can't be reconstructed. So that's one aspect of sets. That's that's what's meant when we say sets are an unordered collection of elements. That's what's meant. Sets also contain unique elements, which means that they don't contain duplicates. So if I wanted to have a list with 1, 2, 3, 2, 3, 2, 1, I've got multiple 3s and multiple 2s and multiple 1s. That's fine. We all know it's why can you do that, right? But with a set, let me actually just duplicate this. We'll make this into a set. Oops. Comment this out. Okay, so so you can see all of the duplicate elements in my list, and maybe I can even make this a little more obvious. If I did, let's do like 1, 1, 2, 2, 3, 3. Like that, right? So we've got all these doubled elements, and those are going to come through not only in the same order in the list, but they're going to come through, in the same amounts that I put them in the same positions. Whereas in a set, as soon as it puts a 3 in the set, there's already a 3 in there. So it is literally just keeping track of the set of data, not the amounts of duplicates, right? So hopefully it's clear that sets are pretty different in terms of like the way that their limitations basically cause some loss of information, right? There's a loss of information in terms of the order, and there's a loss of information in terms of the quantity of elements from converting from a tuple or a list to a set. So where tuples and lists are at least algorithmically interchangeable, a set is not. A set, the kinds of tasks that you utilize a set for overlap very little with the kinds of tasks that you can use a list or tuple for. Now, there can be some overlap. Obviously, with this last question, I was using it as a list, then a tuple, and then a set, right? So in this particular example, a set can be exchanged for a list or a tuple. But that's more of the exception than the rule. So sometimes there's overlap, sometimes you can use, you can kind of trade them out, but generally sets excel at other things. So I've talked a lot about the limitations of sets, and maybe you think sets just suck now, but sets are actually really useful. They're very useful for one particular thing, which is set operations. All right, let's look at set operations. How should we do this? Let's see. What is it? Union, intersection, and difference. So there's these 3 set methods. These are immutable methods, meaning they don't cause a change in the set. So if I have set 1 equals, and usually what I'll do, just for the sake of consistency of always using the same way of creating a set, is I'll usually just create a set out of a list, or actually I'll use a tuple. A little better runtime that way. So let's say 6, 5, 8, 3, 7, and then let's do another one. 5, 1, 2, 9, 7. We'll call this set 2. So I can get the union. Oops. Oh my gosh. There we go. Set 1 dot set, oops, set 2. Let's duplicate those, oops. Duplicate, and we'll do set 1 here, and set 2 here. Okay. We'll just look at these in different orders. Okay, so our union is going to be the set that is that contains both of these. Oops. Of course, I meant to print all these out. I didn't do that at all. So the union of two sets returns a set that contains both all of the elements from set A and set B, right? So notice there are some duplicates. Obviously, you know, there's a 5 in both sets, there's a 7 in both sets. I think that's it. But the union is the result of both of those together. So it's just everything that's in both. And it doesn't matter the order that you do it in, whether it's the union of A to B or union of B to A, it's the same result. So the order doesn't matter. The intersection is the elements that are in common. So the elements that are only a member of both sets. And again, the order doesn't matter. So 5, 7. Oops, keep doing that. Just like that. Is there a chat for this live session? Yeah, you're in it. Where you posted that is the chat. Also, hello and welcome. Cool. So intersection is right here. And then the difference is all of the elements that are in one but not the other. So the reason why I did this, you know, set 1, set 2, and then set 2, set 1 in the other two examples, is that it doesn't matter for the other ones, but it does matter for difference, right? The order matters. So set 1 dot difference set 2 is all the elements that are in set 1 that are not in set 2, and set 2 dot difference set 1 is all the elements that are in set 2 but not in set 1, right? Difference you may recognize as the result of a subtraction operation, and quite happily we can subtract sets from each other, and I believe this is just syntactic sugar for dot difference. I'm I'm like 98% sure that that's all that is syntactic sugar. Make that 99.8. So this is generally what I prefer, to use the subtraction sign for difference, because just clean and easy. And I think it's easier to understand, right? You just think of like, what's set 1, the elements in set 1 minus the elements in set 2. You know, so you take all the elements in set 2 that are also in set 1 and remove them from set 1, and then the result of that is all the elements that are left over. Like I said, none of these are mutable operations. So if we'll just take the prints out so we don't get confused here. If we have set 1, and we'll do set 2 there. So these are in the same. Aha! It came out in a different order. Oh, it's sorted. That's why. I thought it was proving my point, but 3, 5, 6, 7. Yeah, it's just sorted. Okay. Sometimes it'll come out in an arbitrary, like a just kind of a jumbled up random order. And like I said, it's you know, behind the scenes, the ordering of a set, the way it's printed off or iterated through, ways of iterating. I think you can just iterate through a set directly, but the order the elements come out in is arbitrary, and Python will optimize that in whatever way it sees fit. So this code is meant to demonstrate, you know, if I call these, I'm still going to get the original sets. Those are still going to come out in their original orders. Or excuse me, with their original values. So none of these cause a mutation. You might have seen me earlier use the set1.add. So add is similar to append. We don't call it append because append means to place at the end of, and add means to just add in, right? Since there is no end of a set, it's append is just a little bit of a misnomer, but that is sort of the analogy to an append is an add. There are a few other set methods. I think there's a remove. I think there's a pop, which essentially gives you an arbitrary element. Not random. That would not be a way to build a randomness generator. It would be weirdly inconsistently consistent. That makes sense to me, trust me. If that's weird, then just remember it's weird, and don't try to use set.pop to give you a random element. It will give you an arbitrary element. Don't count on it being unpredictable, because that's what I'm saying. That's such a weird sentence, but anyways. Cool. We got a request to turn up the mic volume a little bit. Yes, I could turn up my mic volume a little bit. I'm a little hesitant. I have an issue with the signal to noise ratio. I know there's a little bit of a buzz. So I'll turn it up a little bit. Just be forewarned, I'm going to try not to blow anybody's earphones off their head. Just going real slow here. Oh, that's peaking just a little bit. Check, 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 check. Test, test, test. Yeah, let me know if that's... Oh, gosh, that's peaking just a little bit, I think. Check, check, check. Test, test, test. Test, test, test. Check, check, check. Okay. That might be good. Y'all let me know if that's better. I'm hoping that... I'm really trying to fix that buzz. I think that little background buzz is still there, so apologies if that's still there, but I'm trying to fix that still. Hopefully we're not just stuck with it, but honestly, I don't know. Okay, cool. Yeah, let me know if that helped at all. All right, so let's see. So that's basically sets in a nutshell, right? So like I said, there are other methods. I guess we could come over and just, when we looked at dir of the other two, we'll just see what there is for sets. Yeah, there's quite a number of methods. Oh my gosh. Quite a number of methods. Clear copy. So here's some add clear copy. Forgot about copy, right? Like if you're going to be adding or accumulating onto a set, you're probably going to want to copy it like you would do any mutable type, so they are mutable, like a list or a dictionary. Difference, I don't know what difference update does. Discard, I have used this, but it's been a long time. I don't remember what it does. I'm not sure about intersection update. Is disjoint is subset. Oh, that might actually be useful. Is subset. Although I think there's sort of a quick and easy way to do this in a different way using the other methods that I showed, right? So you could look through here and, you know, get the help docs on any of these that you were curious about. You know, like let's say I was curious about symmetric difference. I could say help set dot symmetric difference. No parentheses, don't invoke it, just do that. I get the help docs on it, or I could Google it or something, right? So yeah, there are a number of other methods for sets. The ones that really I think make them the most useful are the let's say the four that I just talked about. You know, if I put add in there with them, right? So union, intersection, and difference, which you can just use the subtraction operator for, and then add. Those are the ones to know to like start using sets, and then you can kind of learn about the other things as you go if you want. Cool. I'm not hearing anything about if that change to the mic was any good. Let me know if that was helpful to the person asking about that. Or let me know if it needs to be turned back down if it's peaking or if it sounds bad. Okay. Cool. All right. I guess they're going to talk about the remove method here, which I didn't talk about, but why not? I'm assuming that remove just takes a, I mean it has to, that it takes an element in the set and then just removes it. So if we say set dot remove, let's just remove 8. You could say, I guess it removes all occurrences, but you know, since there can only be one occurrence of any given element, it's kind of, I guess, redundant to say that. Right, so that's gonna just remove 8. Got a few questions here. Is there a function to find the complement of all the operations we just covered? A function to find, like the complementary operation for each of those. How would you, yeah, let's see. So Well, I think that what would the complement to a union be? Would it just be it would be the difference of the union and the universal set, I think. So that wouldn't be very, that wouldn't quite be useful. And then the complement of an intersection is the difference. Yeah, so I would say the difference and the intersection are complements of each other, and then the union, I'm not the greatest set theorist in the world, admittedly, but I can't think of what else the complement of the union would be. But yeah, I think it's safe to say the intersection and the difference are sort of complements of each other, because the intersection is all the things that are in common with set 1 and set 2. It's, the result of the intersection is only the things that are in both, and the result of the difference are only the things that are in A and not in B, or B and not in A, right? So that's a little different. And just thinking about like doing this manually, like when you're saying, "Oh, do we have to do this manually?" I think that answered your question just from your response. But these seem like I think these can seem like kind of random tools. Like, yeah, here's 3 random tools. Yeah, have fun. Like, this covers a lot. Like what you can do with this and combining these together is like basically tremendous. I was surprised when I learned. I was like, okay, I got union, I got intersection, I got difference. Like anything else? Like, come on, is that? And yeah, that's kind of it. I mean, there are obviously there are other ones of these, but I think some of these. I recall going through this at some point where I was like, oh, should we teach these other ones? And some of them are like the results of combining, combining these operations in various ways with each other, right? So if all you know is these 3, you can kind of get by and do whatever you need to do. Well, let me put it like this. You can get by at least enough to start. I would never discourage somebody from if you want to learn more about sets, like go through and read the docs for each of these methods and figure out how you could use it. Take a note on it. Imagine a situation and where you might use that, and take a quick note on that or something. So yeah. But yeah, I've done that before. I've gone through all these, and I use them so infrequently that, as you can see, I've forgotten. I no longer remember what a lot of these do, but that's fine. There's a lot of things that I learn and then forget because I don't end up needing them, and but it's like I know. It's like if you see it once, it'll come up again when you need it in the future. So. Anyways, hopefully that's clear. So this lesson is getting into add and remove. I think I went over add sufficiently. I went over the other ones, the union, intersection, and difference, I think sufficiently. So that's remove. Its argument is just an element in the set. Pop, like I said, pop is the one that doesn't give you a random element. It will remove whatever Python thinks is the last element in the set, but that is subject to the sort of the whimsy of the interpreter. And when I say whimsy, I mean like you don't really know. Like it's not entirely consistent. But if we look at this case, right, like I happen to be getting, this is actually a great example. Like I call pop, like I call pop on a list, it's going to give me the last element in the list. Pop is giving me 5, and it's giving me 5 every single time, right? Well, 5 is the second element in the set when I created it, and it's the second element, happens to also be the second element in the set when it's sorted. Oops. Let's see. Let's try this again. Okay, I didn't realize I was being silly and calling pop twice. So that does make a little more sense. So in this case, it's going to pop, I said the last element, whatever it thinks is the first element. Which for this small set, it will sort, and this is what I tend to notice, on recent IPython instances as of last December, November-ish, small sets will tend to be, almost always tend to be sorted. But let's actually see, I'm using IPython. Let's try to use I'll use my built-in Python interpreter and see if I get a different ordering. Hey, look at that. Oh, no, wait. No, it's the same ordering. I was like, it is different, but yeah, that is the same. Okay. Let's try something like this. I just want to see it. It used to be so easy. So easy. Okay. Anyways. So it's kind of funny because this looks consistent, but like you might change the size of your data set and Python no longer thinks it's efficient to sort the set, and you know you have a set with 2,000 elements and it's just like, oh, well, I guess I'll just give you those back in whatever way is most convenient for me, so you'll get a different result. Like I said, that's not random, it's arbitrary. So anyways, gosh, I'm sorry for talking about that for so long. I think I've made my point there. Cool. So yeah, there's some other methods there. We got a question here. Which program do I use to code? So this is Atom. This is the Atom text editor, ATOM. It's what I learned on, and it's it's like weird to like have strong feelings about a program, but I actually absolutely adore Atom. I love this text editor, and I honestly think it's because it's what I learned on, and it's also open source, and I just like using open source programs when I can. I like supporting them by using them and contributing. I just think it's a great editor. It's pretty raw. At this point, you know, shortly after I learned on it, VS Code kind of dethroned it as the industry standard, but this is sort of an old industry standard. If you're looking for a text editor, I would recommend starting on VS Code. VS Code is actually built on, it's proprietary, but it's built on Atom. So they take the Atom code base and expand it and add a bunch of stuff to it and change a bunch of things about it and turn it into VS Code. So there is also an open source version of VS Code, but you have to compile it from source code, whereas you can just go download an already compiled Atom. So for the sake of like knowing what I'm getting and like having a consistent tool that like I just know is going to work, I just prefer to do that. So it's what I'm used to. But I wouldn't recommend it if you're new and you're looking for a tool to start with. It doesn't have like these terminals down here. These don't come with it by default. I have to actually install these. I make a bunch of changes to it and like set it up just how I like it. But yeah. Any crucial plugins we must install for Atom before coding in Python? I would say no. Yeah, I mean, like I said, like there are plugins that are crucial for me. I would definitely start with VS Code. It's such an industry standard at this point. I would say in general, VS Code is kind of a cleaner experience. It's more powerful out of the box. It has more like what I would think of as like IDE or integrated development environment features. It has a terminal built in, which I like that it has a terminal built in. What I want to be really clear about here is like my choice not to use VS Code isn't on the basis of like VS Code being a bad editor. VS Code's a really good editor. It's just not my preference. It's a good editor. It's just I like the thing that I like. You know what I mean? And there's not really a good justification for it. It just happens to be that I use it anyways. Okay, cool. And then so far as like setting it up for Python, so this isn't an add-on for VS Code, but so far as like starting to develop in Python, once you get set up with VS Code, install Anaconda. We have links to that, and Anaconda will install IPython and Jupyter Notebooks. It'll also install, I think it comes with the Spider IDE, although I don't recommend that you start with Spider. Some people really like it, and if you want to work your way up into an IDE someday, then like it's there. But yeah. Cool. Good questions, by the way. All right, so we're about at our normal stopping time. I'm kind of trying something a little different with study halls, where I'm trying to use the material when I'm going through the material. I'm trying to just use it as like a framework, and then just talk about the concepts in the way that I normally would explain them and talk about them, and then sort of go through the questions at the end of talking about those concepts. So I think this is, I like doing things this way, but I want to hear your thoughts. If you want me to just kind of go more straight through the material, I could do that, or I'm happy to do that on request. Like if you're like, hey, would you go through this section in Learn and like, explain this paragraph, or, what's, whatever's happening here, like line by line. I'm happy to do that, but I'm kind of liking this new way of, just kind of using the material as a prompt and then just going off of that and kind of musing on it in the way that I normally would if I were just explaining it. So let me know if that works for you. I'm open to any feedback, any way you think I could improve study halls. I'm absolutely open to hearing about. I know there is that audio buzz issue, and I apologize for that. Like I said, hopefully we'll get that fixed soon. Yeah, let me know if the graphics or the audio, if the font's too small, whatever. Anything that any feedback is very helpful for me. Cool. So I think we can wrap up there. Thanks for the folks who had questions today. What am I going? Oh, we got one more question here. What exactly am I going through? The data science. Yeah, so I'm going through the. Let's see here. Effectively, yes, I'm going through the the basic prep stuff. I think this is actually technically a different cohort. I think I'm on, yeah, I'm in one of the premium prep cohorts, but it's the same material. And in fact, at this point, since basic prep is continually updated, basic prep probably has a few things that this doesn't have. But I just like to go through the, like pick one of the old cohorts and just go through the material there, since it's 99% the same at any given point. And then that way I have like sort of a continual like fresh slate to go through, so when I get through the material in one, I can start over on a fresh slate on another one. But yeah, like I said, it's like 99% the same material. So if you're going through this on basic prep, if there's any divergence, they'll probably be fairly minor, or they'll be like there might be additional what am I saying? Additional material in basic prep, since it's continually updated. Anyways, yeah, hopefully that helps. All right. Cool. Yeah. Well, hopefully everybody enjoyed today's session. I look forward to having you all back. I appreciate all the questions today. And look forward to seeing you all next time. Feel free to DM me. I'll get back to you as soon as I can. Yeah, and y'all have a great rest of your day. Bye-bye.